Hello, my name is Eric Sullivan. I serve as Director of Strategic Development at SewerAI, and I'm also a NASCA certified PACP, LACP, and MACP trainer. Today I am presenting Risk in Rehab with the Smart Project Builder. This is not a new inspection technology. It is not a new lining method. It is a structured framework for turning existing CCTV data into defensible, risk-informed, trenchless capital programs. The problem we're addressing is familiar to everyone in this room. We inspect thousands and millions of feet of pipe. We generate PACP data. We produce rating indices. And then we export everything into spreadsheets. From there, risk modeling becomes manual, subjective, and time-intensive. Capital plans can take months to assemble, and when challenged, they're often difficult to fully defend. Risk in Rehab formalizes that entire pathway into a single, transparent environment. Let's take a look. Risk in Rehab converts inspection data into continuously updated risk scores and rehabilitation recommendations. It ingests any PACP-coded inspection, but when paired with autocode, inspections can be processed at scale rapidly. That being said, manual PACP data can also work. Each asset is receiving two core components: a likelihood of failure, which is derived from condition data, age, material, and other structural indicators, and consequence of failure, derived from contextual factors such as proximity to sensitive facilities, environmental exposure, accessibility, and network criticality. These are combined through a configurable scoring matrix we refer to as a risk recipe. The output is a 0 to 5 risk score for every segment, automatically recalculated whenever new inspection data is introduced. What makes this different is not the math. Utilities have calculated likelihood and consequence of failure for decades. The difference is that the system is always on. It does not require rerunning models, rebuilding spreadsheets, or exporting data to GIS for recalculation. The innovation lies in operationalizing inspection data inside a dynamic planning environment. Instead of static reports, the platform creates a living risk model tied directly to the inspection record. The risk recipes are fully transparent. Engineers can see every factor contributing to a score. Weightings can be adjusted to reflect local priorities such as clay pipe deterioration, deep installations, or assets near schools and hospitals and waterways. And when those weights change, scores recalculate instantly across the network. Another differentiator is what we call the structural benchmark. Each asset is compared against a large national data set of similarly characterized pipes, meaning similar material and diameter classes. Instead of asking, is this pipe a 4.0, the question becomes, how does this pipe rank relative to its peers? Each asset receives a percentile-based score between 1 and 100, providing immediate context for whether a condition is typical or truly anomalous. This benchmark does not replace PACP ratings, rather it contextualizes them. From a practical standpoint, the overall value is reduction of time and subjectivity in capital planning. What traditionally required months of spreadsheet modeling can be accomplished in a single session. Assets can be filtered geographically or by condition class. High-risk segments can be grouped into work packages by basin, material, or rehabilitation method. And estimated construction costs are generated using structured decision logic and localized, customizable cost references, allowing utilities to move directly from inspection to budget development. Importantly, the logic behind recommended actions is visible. Decision trees are viewable within the system. Engineers can evaluate the reasoning pathway that leads to maintain, rehabilitate, or replace, for example. And we're not presenting an opaque recommendation engine, but rather we're formalizing an engineering logic in a repeatable way. From a competitive standpoint, Risk in Rehab is native to the same platform that manages inspection data. It is not bolted onto a third-party GIS tool. Maps are embedded directly in the inspection environment. Risk scores, PACP ratings, and recommended actions are visible simultaneously. Exports are straightforward. Risk scores and recommended actions can be downloaded as CSV files or GIS-ready layers and imported into systems such as ArcGIS or CMMS work order management platforms. The system is platform agnostic. Another key point, Risk and Rehab does not require autocode. It works with any PACP dataset. Autocode improves speed and consistency, but it's not a prerequisite. That flexibility matters for utilities with legacy inspection programs. The impact of this approach is measurable in three areas. First, acceleration of capital planning cycles. Utilities can transition from reactive decision-making to proactive prioritization. Second is improved defensibility. When a government board asks why a pipe was selected for lining over another, the answer is no longer because it was the worst grade. It becomes a documented combination of likelihood, consequence, and comparative benchmarking. Third is long-term sustainability. Across the United States, infrastructure averages roughly 4 to 5 decades in age. Funding gaps are significant, and sanitary sewer overflows remain a persistent issue. Capital dollars must be directed towards assets where both failure probability and consequence justify intervention. By aligning rehabilitation selection with quantified system risk, utilities can reduce emergency failures, protect public safety, and allocate limited funds more effectively. Risk and Rehab is designed to enhance professional engineering judgment, not replace it. Risk recipes can be customized and saved. Decision logic can be reviewed and adjusted. Engineers can interrogate the data set using natural language queries, such as identifying all high-risk segments within a specified distance of a hospital or drafting a summary memo for a capital committee. The system scales across networks of varying size and complexity. Because it operates entirely within a browser-based environment, it does not require local modeling expertise or additional GIS scripting. It transforms inspection data into structured planning artifacts without introducing new workflows that field crews or asset managers must learn from scratch. In summary, Risk and Rehab is a methodological innovation in how trenchless rehabilitation is planned and justified. It converts PACP inspection data into continuously updated risk scores. It contextualizes structural condition using national benchmarking. It formalizes decision trees into transparent recommended actions, and it enables utilities to build defensible capital plans in minutes rather than months. This is not about replacing trenchless expertise. It's about providing a structured, auditable framework that allows that expertise to scale. Thank you for your consideration. I welcome your questions.